All right, so today we're going to take a look at 3.3, okay, which is on what they call the factor theorem, but it really ties in a little bit with long division and finding remainders. So we're going to talk a lot about dividing, which helps us to factor things. Just a couple reminders too for tomorrow, because of the pep rally on Friday. We'll do the first part of the test tomorrow as a take-home. That will be, I think I split it up into 6 questions and 7 questions. So you'll do 6 questions at home, and then you'll do 7 questions when you come in on Friday. I think 7 questions, it should be pretty doable in 45 minutes, I think. Because that's about half the time you normally have, and it's about half the test. So that'll be the plan. But the part that you do the take-home on will only be on what we learned yesterday and today. Some of the stuff from today and the stuff we learned on Thursday, that will be on Friday. So you won't have to do the take-home on material you're learning the same day. Okay, so just a reminder what it means for something to be a root or a zero of an equation. A root is a number that you can plug into an equation, and the answer comes out to 0. So if I had something like this, minus 1, and I asked you for the root of that equation, the answer would be 1/3. If you plug in 1/3 for x, you will get 0. That's the root. And you can actually say that statement 2 different ways. Okay, this abbreviation right here, IFF, stands for if and only if. If and only if is a statement you can read forwards and backwards. In geometry, you learn that as the converse, and it's true. So let me read this statement both ways. Let me read it out kind of a long way. All right. If you have a number that is a root, then it means you can plug it into the equation and get 0 as the answer. The other way you can read it is if you plug a number into an equation and get an answer of 0, then that number is a root. So it's just reading the statement. If it's a root, then you can plug it in and get 0. If you can plug it in and get 0, then it's a root. Just reading it both ways. And they're both true. Any question on that? Okay. So what we're going to do is we're going to look at how do we use long division to find roots of polynomials. And before we even do it with long division, we're going to try it with just numbers, right? Just to illustrate the concept. But the concept that we do with numbers is exactly the same thing with a polynomial. It's going to be the same idea. So let's say that I wanted you to factor the number 12. And I told you that 3 is a factor. How can you get the other factor if you don't know what it is? So I want you to factor 12, and I'm telling you 3 is one of the factors I want you to use. How do you get the other one? Yep.
Divide 3 by 12. 12 by 3.
Divide 12 by 3. Yes. If you divide it out, you'll get the other factor. Right? So basically, if I tell you 3 is a factor of 12, that means 3 times something gives you 12. Well, divide both sides by 3, and you would get whatever the something is by itself. So when you do that in this case, you get 4. Does anybody remember what you call this? When you divide 2 things, what the answer is to a division problem? When you add 2 things, it's the sum. Subtracting is the difference. What's this?
Product.
Product is when you multiply. Yep.
Is it the quotient?
It's the quotient. Okay, so if you're trying to factor something and you know one of the factors, divide by the factor you know, and the quotient is the other factor. So I took 12, divided by the factor that I knew, and the quotient is the other factor. And I can check it. 3 times 4, yes, it does give me 12. Now, the important thing is, when you divide 3 into 12, what's the remainder? If you think about it like with long division. Yeah? 0. Anytime you divide a number by a factor, and I can even extend that to be a little bit more general. Anytime you divide something by something else, if the remainder is 0, then what you divided by must be a factor. If I divide 12 by 6, I get a remainder of 0, and that's because 6 is a factor of 12. If I divide 12 by 5, I get a remainder of 2. That's because 5 is not a factor of 12. Okay, all these ideas are going to apply to polynomials. We're going to be looking for remainders of 0, and that will tell us if something is a factor of something else. Okay, looking at the remainder. So that's important. Now, with a polynomial, the division isn't quite as easy as that. You can't just really do it in your head. So I'm going to show you the steps for how we can do division with polynomials. Okay, and it's something you probably saw in Algebra 2. But sometimes we don't remember it that well, so we'll take a look at it. I just said that to you guys. Okay, again, if you divide 2 things and you get a remainder of 0, then what you divided by is a factor of the numerator. And we might wonder, well, what do we care about factoring something? Well, what's the point of taking something and factoring it? Like, why would you write 12 as 3 times 4? Well, for that, there's not really much of a point. But where we use factoring is with polynomials. If I gave you a problem like this, let's say, and I said, tell me the roots, you have 3 seconds. Right, nobody tell me the roots. So, maybe that's because it's not that easy to do that problem in 3 seconds. But if I put up this version, which is the same problem, just written factored, hopefully you could look at that and say, oh, the roots are -1, -7, done. Okay, it's much easier to determine the roots now that you've factored it. Okay. And we're going to get into factoring not just quadratics, but we'll factor cubics as well. Right? So in order for a cubic to be factorable, some special things have to happen. So we'll see what you have to look for when you're factoring a cubic. So, everything I just described to you about dividing a number by the factor you know, and the quotient being the other factor, we're going to apply that process now to a polynomial. So let's say you didn't know how to factor this. I said, I want you to factor x squared plus 8x plus 7. And I'll tell you that x plus 1 is one of the factors. And you said, I still don't know how to find the other factor. What you could do, yeah, this is the long way, I'm hoping you could factor that, but if you couldn't, you could take x squared plus 8x plus 7, you could divide it by x plus 1, and when you do all that out, the answer that you will get would be x plus 7. We just have to learn how to do this problem out now. All right, so let me give you the steps for long division with polynomials. It's going to be very similar to the steps you know for long division with regular numbers. Divide, multiply, subtract, bring down. So the first step is really just setting the problem up. And we want to check if the dividend, if you're confused what the dividend is, dividend, divisor. So if the dividend is missing any terms, we need to fill in a placeholder. Right? We need to fill in a 0x to the whatever power we're missing. So in other words, every power from the highest to the lowest has to be represented in the dividend, even if that power is a 0. So that's step 1, setting it up. Step 2 is you're going to take the first term of the number on the outside, and you're going to divide it into the first term of what's on the inside. So take the first term of the divisor and divide that into the first term of the dividend. Once you do that, you're going to have something right there. Something. Now you're going to take the answer that you just got and you're going to multiply it back out to the divisor. And the divisor is usually going to have a couple terms in it, so it's like a distributive property. So multiply the answer that you just got from step 2 by every term in the divisor. And as we do that, we're going to start lining things up under the dividend. And we have to line things up in the right column. What I mean by that is like terms. All your x cubes are going to go in one column. All your x squareds in another column. Your x's in a column. And your numbers in a column. So we're going to divide our term in. Then we're going to multiply what we got in step 2 back out to each term in the divisor. And what's the next step usually when you do log division? You divide, multiply, and then you have numbers in columns. Anyone remember what you do with those numbers? Yeah? Subtract. Okay, the next step is you subtract your columns. In this case, our columns are going to have variables. In regular log division, it's all numbers. So we're going to subtract the columns. That's technically step 3. And after you subtract your columns, then you have to continue this process again. So we bring down the next term, and we repeat it. We keep repeating it until we're done. But the question is, how do you know when you're done? Well, one of two things is going to happen. You're either going to keep going until you end up with a remainder of 0, in which case you're done, or the degree of the divisor is less than, the degree of the remainder is less than the degree of the divisor. So let's go through a problem and then we'll come back to these steps as we go through it. So if there's any confusion on what we mean by a certain step, I think it'll make more sense when we do a problem. Anybody need to copy down the steps? All right. So let's divide x minus 3 into x cubed minus 8x plus 3. What's the first thing I have to do in this case, just to get this problem set up right? Look back at your steps. We can't start this problem yet. It's not set up right. Francesca?
Do you have to do the OX, the N?
Yeah, and what term are we missing here?
The 2.
Yeah, the squared term.
Yeah.
So what am I going to put as just like a placeholder for that?
So you're going to put 0x to the second.
0x to the second. There are no x to the seconds, but we need to leave space for them. Because as we do the problem, we might get some. So leave room for them. The 8x and the plus 3. Okay. Any questions on setting it up? Now we're ready to start. So step 2 says take the first term of the divisor and divide it into the first term of the dividend. Matt, what's the first term in my divisor?
X.
Yep.
Cube.
X. Divisor's on the outside. And what's the first term in my dividend?
X. 3. Negative 3.
Where's my dividend again? Make sure we know what we're looking at.
X cubed.
X cubed. Right. The first term of my divisor is x. The first term of my dividend is x cubed. We want to divide x into x cubed. And then we're going to write that answer down. So Abigail, what do I get if I divide x into x cubed?
That x squared is our
Yep, x squared. Doesn't matter where you put that. You can put that anywhere you want. Just put it above the line. Now, we're going to take and multiply back out the answer that we just got to each term in the divisor, and now we have to line things up in the right columns. So Casey, if I multiply this back out, what's x squared times x? X to the third. And you know you did this part right, because if you multiply what you just got times x, it should always give you this term. If it doesn't, you did something wrong. All right, and now how about Tyler? What's x squared times negative 3x?
Negative 3x. Or there's no x here,
So wait, can you tell me again, what did I ask you to multiply?
X squared times negative 3x.
Times x squared times, we did that.
It's negative 3x squared.
Yeah, so x squared times negative 3 is negative 3x squared. And it has to go in the column with the x squareds. All right, and how about Zach, what do I do with these columns now? Subtract. And what I like to do is put it in parentheses, so you remember you're going to subtract the whole thing. Right? Chris, what's x cubed minus x cubed? 0. That should always happen. Ethan, 0x squared minus 3x squared.
It's in mine, but it's 3x squared.
3x squared. Right. And Ashley, what do I do now to start the next round of this process?
Drop down the negative x squared. Or a negative x, sorry. Like bring it down to the 3x.
Can you tell me what I'm bringing down again?
The negative 8x.
Yes. So bring down the negative 8x. Thanks, you're good. So bring down the negative 8x, and now we'll do it again. Remember, we have to keep going until the degree of my remainder is less than the degree of my divisor. What's the degree of my divisor right now? Yep, Sarah? That's degree 1. The degree on the inside started off as a 3, now it's a 2. It's going to go down by 1 each time we do this. We have to keep going until this number is less than that number. So let's do it again. Take the first term on the outside and divide it into the first term on the inside. So Jake, what do I get if I divide x into 3x squared?
Wouldn't it be 3x?
3x. Now we're going to multiply that back out. Francesca, what's 3x times x?
3x times x.
Should be 3x.
The only way something can't change is if you multiply it by 1. So we're multiplying 3x times x. We can't get 3x back.
3x to the second.
3x to the second. You got that? And Matt, what's 3x times negative 3?
Negative 9x.
Negative 9x. Right. And Abigail, what am I going to do with those columns?
I'll subtract.
Subtract. And Jack, what's 3x squared minus 3x squared?
0.
0. So that's gone. And Casey, what's negative 8x minus 9x?
7x.
So when you do minus a minus, what's going to happen?
1.
Yeah, it's going to become a plus. So negative 8 plus 9 is plus 1x. Or just x. Now, the degree on this is a 1. The degree on my divisor is a 1. I got to go one more step. So bring down the 3. And let's do it one more time. So Ethan, what do I get if I divide x into x? 1. If all they wanted was the quotient, we're done. The quotient in this problem is x squared plus 3x plus 1. If we want the remainder, we have to finish it off. So Chris, what's 1 times x?
X.
And 1 times negative 3?
Negative 3.
Negative 3. And Zach, what am I going to do with those columns?
Subtract.
Subtract. Good. Tyler, x minus x.
0.
That's gone. And 3 minus minus 3. Ashley?
6.
6. That's my remainder. So, a couple ways we can write our answer. The quotient is x squared plus 3x plus 1. And the remainder is 6. That's one way. Or you can also write it the same way you would write long division when you learned it in elementary school. Right? Let's take 17 and let's divide by 5. What's the quotient when you divide 17 by 5? Tyler?
3.
3. And what's the remainder?
2.
2. So another way you can write your answer is quotient plus remainder over divisor. That's another format you can put your answer in. And look at how that would work here. Quotient is 3 plus remainder is 2 over divisor is 5. 3 plus 2/5. Or if we wrote that as a mixed number, it's 3 2/5. And that's what 17 divided by 5 is. 3 2/5. So you can apply this exact same thing to this problem as well. Quotient, x squared plus 3x plus 1, plus remainder over my divisor, x minus 3. Both of these answers are correct. If you're wondering, well, which one would I ask for on the test? You'll know by how the problem is set up. If there's a box that says quotient, and then there's a separate box that says remainder, I'd like you to do it the first way. If it says to divide two things, and you just have one box to write your answer in, then you got to put it the second way. Questions on that one? Let's try another long division one. So this one, there were some missing terms, and I already filled in the zeros for you. The squared term and the linear term were missing. So step one is done. Jake, what's the first term in my divisor?
2x squared.
Yep. And the first term in my dividend?
2x. So 4.
So we're going to divide this into that. And Sarah, what do I get if I divide 2x squared into 2x to the fourth?
X to the second.
X to the second. Okay. And Francesca, if I multiply that out, what's x squared times 2x squared?
2x to the fourth.
To the fourth. So I got that. Matt, what's x squared times x?
X cubed.
X cubed. And Abigail, what's x squared times 1?
X squared.
X squared. And Casey, can you tell me what do I do with these columns? Subtract them. So let's do it. Jack, what's 2x to the fourth minus 2x to the fourth?
0.
0. That always happens. Ethan, negative x cubed minus x cubed.
Negative x to the second.
Can you say it again?
Would it be 0?
Um,
Negative x to the second.
If it was 0, then it would have to be negative x cubed plus x cubed. But we have negative x cubed minus x cubed.
Negative x to the sixth.
So remember, when you're adding and subtracting like terms, the exponent never changes. The only way the exponent can change is if you get 0. Then the term is gone. But other than that, you have to end up with a certain number of x cubes when you're done. Chris, can you help us out with that one?
It would be negative 2x cubed.
Negative 2x cubed. All right, so we're not really going over combining like terms. That's more of something from Algebra 1. So if you're having any kind of trouble with combining like terms, definitely come talk to me. But it's just not something we're going to spend like a whole couple days on learning how to do. All right, so we got negative 2x cubed. And now 0x squared minus x squared. Zach, what's 0x squared minus x squared?
X squared.
That would be 0x squared plus x squared.
Oh, negative x squared.
Negative x squared. Okay. Tyler, is the degree on the inside, where I'm doing the work, smaller than what's on the outside?
No.
No, not yet. I have a 2 on the outside, I have a 3 on the inside, so we gotta do it again. So Ashley, how do I start the process for the next round?
Drop down to 0x.
Yep, bring down that 0x. And Jake, what if I divide 2x squared into negative 2x cubed?
Would be negative x.
Yep, negative x. Multiply it back out. Sarah, what's negative x times 2x squared?
Negative 2x.
Negative 2x cubed. And Francesca, what's negative x times positive x?
Negative x times positive x, negative x.
So remember, we're not multiplying by 1. So we're multiplying two things that are not 1, so the answer can't be either one of them. It's going to have to change.
Isn't it x to the second?
Positive or negative?
Negative x.
Negative x to the second. And Matt, what's negative x times 1?
Negative x.
Negative x. And Abigail, what do we do with the columns? Subtract. And Jack, what's negative 2x cubed minus negative 2x cubed?
0.
0, because that becomes negative 2x cubed plus 2x cubed. Casey, what's negative x squared minus negative x squared?
Negative 2x squared.
So what happens when you do minus a minus? It turns into a
Oh, sorry.
0, right? It turns into a plus. So negative x squared plus x squared. So we just got two things to cancel at the same time, which basically means we're going to be done now. We're not going to have to do this again. The last part, Chris, 0, x minus x.
X minus ABX.
X. Bring down the negative 2. But now, the degree of what I have left here is a 1. The degree of what I have on the outside is a 2. 2 doesn't go into 1. You can't do that because 2 is bigger. So I'm done. My quotient is x squared minus x. My remainder is x minus 2. And I'm only writing the answer this way. I didn't do it the other way. Okay, any questions on how? So I think for some people it may be a little bit of practice that we need with just making sure when you multiply out, what you get when you do that, and then when you combine like terms from the subtracting. Especially things like minus a minus becoming a plus. There's lots of little things, and unfortunately, if you mess up one, it messes everything up. So. All right, so that's the long division. So let's take a look at, hold on, let me see. Let's look at what's called the remainder theorem. I'm going to go to that. So the remainder theorem is a way that you can quickly find the remainder if you don't care about the quotient. Now, unfortunately, the remainder theorem only works in a very specific situation. It only works when you're dividing by something of the form x minus c. C would be a number, like x minus 5 or x minus 8. So you'd have f of x on the top, you divide by x minus c in the bottom. If you're dividing by something of the form x minus c, you can take the number that comes after the minus sign. So block off the x and the minus, look at what you have left, and fill that number into the numerator. And it will automatically give you the remainder. It won't give you the quotient. But we did a problem like this earlier on. So let's go back and try this theorem. So remember, you have to have a divisor that's x minus a number. Is my divisor in example 2 x minus a number? Okay.
You said your divisor, right?
My divisor, it has to say x minus and then a number.
Oh, no.
No. This is way more complicated. It's 2x squared plus x plus 1. So no. How about this one? Is my divisor x minus a number there? Yes. So then the theorem says you can take the number after the minus sign, fill it into what you're dividing into, and it will tell you the remainder. So let's fill 3 in for x and watch what happens. 3 cubed minus 8 times 3 plus 3. What's 3 to the third power? 3 times 3 times 3. Yep. 27. What's 8 times 3? Chris? 24. 27 minus 24 is how much? Yep. 3. 3 plus 3 gives me 6. Let's scroll down and see what the remainder was when we did this problem. 6. So what we just did is a quick way to find the remainder. But it only works if you have x minus a number. If you want to find the quotient, this little trick doesn't do anything for you at all. You have to go through and do the process out. If you're dividing by something more complicated, like something squared, the trick doesn't help you here either. So it only works for x minus a number. And that's called the remainder theorem. So on the test, I might give you something like this, like x minus 4 divided into 8x to the 53rd minus 4x cubed plus 7. And if I said to you to find the remainder there, and you wanted to divide it all out, remember the first thing you have to do, fill in zeros for every term that's missing. You'd have to fill in zeros for every term from the 52nd power down to the 4th power. So you have to fill in all those zeros, and then also 0x squared and 0x. And then you'd have to do it all out. That you're not going to be able to do a problem out that has 53 columns in it. You're not going to finish. So the quick way here is to use the remainder theorem. You're going to get a pretty big answer, but all you have to do is fill in 4 for x, and you're done. So let's try on this one. Find the remainder when f of x is divided by, and I actually have two problems. Let's first find the remainder when we divide f of x by h of x. And then let's find the remainder when we divide by g of x. And you might say, well, wait a minute. He said it has to be x minus a number. How can we do g of x? Well, hold on a second. We'll get to that. That's pretty easy. So let's start with f of x divided by h of x. Here's the remainder when we divide f of x by h of x. Okay. Is h of x in the form x minus a number? Yes. What is the number that comes after the minus sign? Chris? 3. 3. So what we want to do to find the remainder is fill 3 into the numerator, or we also call it the dividend. That's your remainder. Just do that out. So what do we get? 3 cubed is 27. 3 to the second power is 9 times 2 is 18. Plus 3 minus 5. So 27 minus 18 is going to give me, what, 9? Plus 3 minus 5. You always go left to right when you do addition and subtraction. That's 12 minus 5, which is 7. Now, anybody remember, what did we say earlier? If the remainder comes out to a certain number, then that means something. Anybody remember what number the remainder has to come out to for something special to happen? We talked about this earlier with factoring. What did we say in relation to factoring? If the remainder comes out to a certain number, then it means something. Yeah?
That's a factor?
How do you know something's a factor?
When it's like a full number, it doesn't have any decimals.
I don't think we said something is a factor if it comes out to an integer when you divide. But we did say if the remainder comes out to, yeah?
0.
0. We said if the remainder comes out to 0, then what you divided by is a factor. So, is h of x a factor of f of x? Jake? No. We didn't get a remainder of 0. So if you were trying to factor f of x, h of x is not the way to do it. It does not work. Now let's look at g of x. I want to find the remainder, but I don't want to do out the whole division problem. I could. It's only x cubed. It wouldn't take me that long to do it. But how can I think of g of x a little differently so that it fits the pattern of an x minus a number? Because the remainder theorem only applies to x minus a number, right? I don't have x minus a number in g of x. Yeah.
Can you take the opposite of g of x?
All right, so could you tell me another way to rewrite that?
So could you do like negative x minus 1? Or could
So that wouldn't be equal to that. That would be the opposite of that. We need something that's equal to that. I'm kind of on the right idea. Yep.
X minus negative 1.
That's exactly the same problem. Now it's of the form x minus a number. So now we can use the remainder theorem. All right, so now let's find the remainder when we do f of x divided by g of x. So Matt, how am I going to find the remainder when I divide by g of x?
Would it just be 1?
So what's the process? How'd you get that? It's going to take a little bit of arithmetic. I can't quite do all that in my head that quick. So how do you do it?
Distribute the negative.
No, we don't distribute. We have to plug in something somewhere. So first of all, what do we have to plug in?
A negative to x plus 1.
We're going to plug in, can you say it again? What number?
1 or x.
Number.
I said 1.
1. No, not 1. What are we plugging in, Sarah?
Yeah.
Yes, we're plugging in negative 1. Remember, you look at the x minus, and you look at what comes after it. So we're plugging in negative 1. Now, can someone else tell me where we're plugging it in, or what we're plugging it into? Yep.
All the x's
Where?
in f.
In f of x. So h of x is done. We're not even using that anymore. So that was a separate problem. So we're plugging in negative 1 into f of x. So that is how we're going to find the remainder. Doing that out, that's pretty easy. But any questions on why I'm plugging in a negative 1? Or about why I'm plugging it in right here? Okay, so let's do that out. So it's negative 1 cubed plus, or minus 2 times negative 1 squared minus 1 minus 5. Okay, Casey, what's negative 1 cubed? Negative 1. Francesca, negative 1 squared.
Negative 1.
So what does negative 1 squared mean to do?
Oh, would it be positive?
Positive 1 means negative 1 times negative 1. So that's positive 1 times negative 2. So it turns back to negative again. Minus 1 minus 5. And Abigail, negative 1 minus 2.
Negative 2.
Minus 1.
Negative 4.
And minus 5 more.
Negative 9.
Negative 9. So there's my remainder, negative 9. So what does that tell me about g of x? Chris?
G of x is not a factor of f of x.
Yep. G of x is not a factor of f of x. So both of these are not factors of f of x. So what is a factor? Well, we're not really answering that right now. But these are not. Questions on that? So that's called the remainder theorem. Okay, there will be a question on the test that uses the remainder theorem, and it's probably going to be some kind of absurdly high exponent here, like in the 30s or 40s. Something that you can't do the long division out in a reasonable amount of time. And I wouldn't ask you for the quotient of something like that, because that would take a very long time. But I would ask for the remainder, and that's quick. Alright. So factor theorem. Okay, so I think it's the last thing they talk about. Yes, factor theorem. So the factor theorem, basically, we've been kind of hinting at that. It's basically the remainder theorem when you get 0. Then that means what you divided by is a factor. So if you have a polynomial and x minus c is a factor of that polynomial, then that means this number right here must be a root. Okay, because think about it. This is the number that you plug in to check the remainder. That's the number you plug in to check the remainder. When you plug that number in, we're hoping to get a remainder of what if something is a factor? Remainder of 0. That's the number that you plug in. If you plug that number into a formula and you get 0 as the answer, well, we know the remainder is 0. But what's another name for a number that you plug into a formula and get 0 as an answer? That number is called the what of the equation? I gave you an example. It said like 3x minus 1 equals 0. And I said x, when x is 1/3, it's the what of your equation? The root. So if you plug in this number and check it, and the remainder comes out to 0, then that means this number is a root of your equation. It has to be. Because a number that you plug in and get 0 means it's a root. So this is really two things. It's the number that you can check to find the remainder, and if you plug that number in and it comes out to 0, this number is not only the number you use to check for the remainder, but that number is also called a root. If you plug in that number and you don't get 0, then that number is not a root. Okay, you have to plug it in and get 0. Right? So it kind of tells you two things. It tells you that it's a root, and it tells you since the remainder is 0, it's a factor. Okay, remainder 0 means it's a factor. So I want to show that x plus 2 is a factor of this. And I don't want to do out all the long division. So all I have to do is show that if I divided x plus 2 into that, show that I get a remainder of what? Yeah. 0. Basically, plug in a number for x here and show that it comes out to 0. And that will prove this is a factor. What number, now be careful, what number would I plug in for x to show that that is a factor? Or what number would I plug in for x here to find the remainder when I divide by x plus 2? Yep.
2.
We'd plug in 2 if it was x minus 2. So what are we going to plug in for this one? Yep.
-2.
-2. So we're going to plug -2 in for x, and that will tell me the remainder when I divide by this. That's all I care about. So let's fill -2 in. Okay, Tyler, what's -2 cubed?
I don't have the biggest brain for it now.
Well, think about what does that mean to do? Negative 2 cubed means to do what
2
times
times
what?
2 times 2.
Except negatives. Yeah.
Yeah.
So,
Oh, 8.
what's negative 2 times negative 2?
Positive 4.
Times negative 2.
Oh, negative 8.
Negative. So we get negative 8. Francesca, what's negative 2 squared?
Positive 4.
Times 5?
20.
20. Matt, 5 times negative 2?
Negative 10.
Minus 2. 8, negative 8 plus 20 gives me 12. And Abigail, 12 minus 10?
2.
Minus 2?
0.
0. So what's the remainder when I divide x plus 2 into that cubic? Yeah,
Would be 0.
I get a remainder of 0. And what does that mean about x plus 2? It divided in without a remainder. Yeah,
That's a factor.
it's a factor. Exactly. So x plus 2 is a factor of this. So if I was going to factor it, it would be x plus 2 times. How would you get the other factor if they wanted it? The other factor would be your what? Yeah, Matt?
The cube.
Your what?
The cube.
What's the
plus
cube?
I forget what's called. I was about the quotient.
Anybody know what he's getting at? Yeah? It's the quotient. So if you had to factor this, you'd have to do out the whole long division, which I'm not going to do. But the quotient is the other factor. Okay, any question on that? All right, so let's, I think that's it. So this kind of summarizes all the different things we've said. If you have, let's just make up something like this. In that case, the root of that equation is negative 3. If you plug in negative 3 for x, you will get 0. So in my example, let's pretend like c is negative 3. I'm saying negative 3 is a solution to this equation. If you can plug in a number and the answer comes out to 0, then that number is called the 0 of your equation. That number is also called the root of your equation. And the next one, this is the most important one, is if you know that a certain number is a root, then x minus that number has to be a factor. Think about that in terms of a quadratic. I think I used this example earlier. That factors as x plus 1, x plus 7. Zach, what would you plug in here to make x 0? Or make this first factor 0?
Negative 1.
Negative 1. So he just told me negative 1. And what about here?
Negative 7.
Negative 7. Negative 1 and negative 7 are the roots of that equation. But watch what happens if I write x minus the number he just said. X minus negative 1. That's a factor. X minus the other root that he just said, negative 7. That becomes x plus 7. So if you know a root and you write x minus that root, then you can get the factor of the equation. That's That's important, because in the next problem, I'm going to give you two numbers like this and say, tell me the factors of the polynomial. So you would have to work from this to give me that. And then you could FOIL that out and even give me the step above it. All right, and if something is a root, that means the x-coordinate is 0. What does that mean? Oh, I'm sorry, the y-coordinate is 0. Think about when the y value is 0 on a graph. That's where your graph crosses the x-axis. And what do we call that? What do you call where your graph crosses the x-axis? Yeah.
Would it be the 0?
It is the 0, but there's another name for it graphically, if you're thinking of it, yeah?
The x-intercept?
The x-intercept. So the root, or the 0, is also the x-intercept of your graph. It's where it crosses the x-axis. So these all mean the same thing. -3 is a solution to that equation. -3 is a 0. -3 is a root. -3 is an x-intercept. They all mean the same thing. So, let's look at this. Find a third-degree polynomial that has coefficients that are real numbers, so no imaginary numbers, nothing like that. And the roots are -2, 1, and 3. So start with -2. If -2 is a root, what else does that mean? It means -2 is a 0, -2 is an x-intercept. I'm not interested in those, but it means something else, and I put an asterisk next to it. Yeah?
X plus 2 is a factor.
Exactly. If -2 is a root, try to think of something you could plug it into to get 0. X plus 2. If you fill it in right there, you get 0. How about if 1 is a root? What would that come from? Yep.
X minus 1.
It would have to come from the factor x minus 1, because now you can fill in a 1 and you get 0 there. And what about if 3 is a root? Yep. X minus 3. So if you were to type that in on your calculator and graph it, it would cross the x-axis at exactly those spots. Yeah, but that's the answer. Okay, it's a little bit different. On that one, I'm telling you the roots, and you have to work backwards to give me the problem that it would have come from. So that's how you do it. Okay, and last one. So this one is back the other way. I'm giving you the problem again. I want you to tell me the roots. And I'm giving you a hint here, which is to use factor by grouping. You use factor by grouping generally when you have 4 terms. 1, 2, 3, 4. Factor what you can out of the first 2, and then factor what you can out of the second 2. So what do the first 2 terms have in common that I can factor out? Sarah?
X squared.
Okay, if I factor out an x squared, what would that leave me with in parentheses? Chris?
X plus 2.
X plus 2. Now the whole goal of factor by grouping is to get x plus 2 again over here. If we do, then we can use factor by grouping. And I'm telling you you can, so that's what's going to happen. But let's look at these two. What can you factor out of negative 4x minus 8? Yeah, Jack?
-4.
Let's factor out a negative 4. And Jack, what do you multiply negative 4 by to get negative 4x?
X.
And what do you multiply negative 4 by to get negative 8?
2.
Positive 2. So So look what happened. X plus 2, X plus 2. So now, think of it that way. This is the first part. This is the second part. They both have an X plus 2. Factor that out. And then you're done with the factor. If you factor out an X plus 2 from what I have underlined right there, what would be left? Seven. X squared. And if you factor an X plus 2 out of what I have underlined right here, what would be left? Yeah. A negative 4. And you can check it. Distribute that back out. You'd have X plus 2 times X squared. Yep. X plus 2 times negative 4. That's what we have right there. And now set each of these factors equal to 0 and then solve. Okay. What would make this equation equal to 0? Yeah. Negative 2. How would I solve this for x? What's my first step? Yep.
You would move the negative 4 over to the right, so it would be positive 4.
Yep, so we're going to move that to the other side by adding it. Now what? Okay.
Yeah, square
I already have it squared.
it. The square root.
Square root. Yeah, I want to square root it. And what happens when you take the square root of x squared? What do you get?
Cancel it out. Pushes
It cancels out. You just get x. Now, what's the square root of 4?
2.
And?
And negative 2.
And negative 2. So you always should have as many answers as this exponent. And we do. It's just one of the answers is repeated. The answers here are 2, negative 2, and negative 2. You don't have to tell me negative 2 is an answer twice. If you just said positive and negative 2, that's fine. And sometimes that happens. Sometimes you get answers here that are different than what you had here. Sometimes you get answers that are the same. In this case, one of them was this. So that's 3.3. So the test, the take-home mark tomorrow is going to cover 3.2 and some of 3.3. It'll be 6 questions. So this will be your last homework assignment this week in the book.